Good morning, everybody. We're going to talk today about sea level change and the development of the Texas coast during the last glacial cycle, both mostly the landform development, but also a little bit on the indigenous peoples. I want to thank, before I start, some people that helped me a lot on this. Dr. John Anderson at Rice University, who's done coastal geology in Texas for many years. Don Dobesh from CGG Geophysical helped with some of the modeling, and Carrie Burnley, who helped with some of the ArcGIS applications. All of this was done as a little project to work on a prehistory of Houston and Southeast Texas, including Galveston Bay, both the landscape and the culture, which is come out in a book. All right, and oh, by the way, and thank you very much, ARI, for inviting me here to give the talk. So let's get started. This is today on the Texas coast. You can see Galveston Bay there. The red outline is just the Southeast Texas area that I'll be talking about, and you can see Central Texas up to the left. Now, this is what the coastline looks like today. Let's take a look at what the coastline looked like during the last glacial maximum 22,000 years ago. As you can see, we've got a series of rivers that are cutting across the paleo shelf, making deep canyons. And the coast itself is about another 150 miles out to sea, relative to where it is today. It was about this time that people started to arrive in Texas. The oldest well-studied site is the Galt site up there in the northwest corner there in Central Texas, where about 18 to 20,000 years BP are the oldest of the remains there. And then a lesser known and lesser studied site down near Corpus Christi called Petronilla Creek. And so that's what we have, nothing inside the Southeast Texas area at this time. Now, if we talk about the last glacial cycle, what do I mean? If you look at the top, that's a sea level chart for the last 800,000 years. And what you can see is that there we go. There's a periodicity to the sea level over there, about 120,000, every 120,000 years we go through a cycle. So on the left in blue is the last of those cycles, which I've enlarged down at the bottom. And you can see that 120,000 years ago, off to the right, I'm having a little trouble with this pointers this morning, but anyway, off to the right, you'll see a warm time highlighted in red, and then a fall, and down to the last glacial maximum where you see the white arrow, and then a climb up again to the present day on the left. So that's what we're going to look at, is not just the climb out of the last glacial maximum, this climb to the left, but the fall as well. And one thing you notice about the fall, it's a long period of time with a lot of up and down. And those ups and downs are, peaks and troughs are records of very sharp lowerings and raisings of sea level. And during this time, as you'll see later, we have major incisions on rivers on the Texas coast. Okay, so here we are today, and what I've highlighted in orange along the coast are a string of barrier islands and Chenier Plain in Louisiana. It's a very, very quiet coast. Geologically, not a lot going on. If you look at the yellow pattern at the heads of the bays where streams come in, we have small bayhead deltas, not bringing very much sediment at all. It's a very quiet coast. So that's where we are, the red arrow there. We're at the very end of this cycle. Now we're going to move to the very beginning of the cycle, which is here. Again, look at the red arrow on top. So that's that warm period 120,000 years ago. And at this time, we had again, barrier island bars, you can see highlighted in orange. Those are called the Ingleside, that's the Ingleside trend. They're sandbars buried in the coast today that are a remnant of that. And you can map with cores, map the old coastline, which is there. And as you can see, the coastline is inland from where it is today, kind of suggesting that, you know, maybe we're not at the end of this glacial cycle yet, and that there's more sea level rise that's purely natural. Okay, now, so next what's going to happen is we'll get the early part of the fall, and what happens on the coast, which is a very, very quiescent coast now with not a lot going on, is immediately we get into basically all hell breaking loose geologically. You'll notice in the interior, those brown patterns, that's where rivers are incising deeply into the coastal plain. And all that material is coming out and forming deltas, which start to move out across the shelf very rapidly. As you notice, they're busting through the old line of barrier island bars. And though that's so what we're looking at now up on the upper left are some of these early incisions, very dramatic drops in sea level as it bobs back and forth. This is just what the front of the Brazos Delta looked like, give you an idea of the geology. These are glacial foresets in yellow moving southward at a very good clip. So now we're a little bit later. Now we're say 20 to 60,000 years ago in the late part of the fall. And yeah, what you can see here highlighted, so the shelf edge deltas down at the bottom, those yellow deltas, you can see we've almost got out to where the current shelf margin is today. And in green, I have highlighted what we call Deweyville River terraces. They're cut and fill patterns that are set up by the up and down pattern of sea level rise and fall, which is highlighted in the upper left by those white arrows that you see. So the way this works, if we take a look just at a cross section across the Trinity River, if we start at the top, you'll see that there's a channel cut into the coastal plain. That's one of these sharp drops. And then the next frame, you'll see that it's a, I can't point, but the channel has filled with green, and then it cuts again, and the green in the coastal plain is cut a little bit more, and then it fills again with that light green pattern, and then it gets cut again and fills again and cuts again and fills again. That's the pattern as each of these rise and falls in the sea level causes inland in these rivers, this so-called cut and fill pattern. Very distinctive. Then finally, we reach the last glacial maximum, which you can see in the upper left. That's the lowest point in sea level. And at that time, these canyons, these cut canyons, are all the way out. There's no fill right now. It's all cut. And the reason the cut happens, by the way, is as sea level drops sharply, that lowers the base level for the rivers, and they cut. And where does that material go? Well, it goes into the shelf margin deltas, but at this time, as you can see at the bottom, we have the material from the rivers dumping all the way across the shelf margin into deep water, making turbidites and debris flows that have been dated to around 15 to 24,000 BP. In other words, the time of the last glacial maximum. And just a block diagram kind of shows you what it looks like. So we have incised river valleys coming across the shelf and then dumping debris flows off the deep end there. So that's what it looked like at 22,000 years ago. Now we're going to start to refill everything. And here I'm taking just the fall up in the upper corner, sorry, just the rise to the present day. And I've enlarged this, and you can see there's a purple curve. That's Basile and Donahue. That's a Florida Gulf of Mexico curve that they put together that's quite useful. And then in blue, Milliken et al., that's another sea level curve that is from Texas data that we'll use for the uppermost part. So you can see the last glacial maximum down there at the bottom right. And in blue there, the bar at the bottom that says turbidites on it, that shows you the time which these turbidites were spilling across the shelf margin. So what we're going to do is make a series of maps as sea level rises. And you can see those little balls there correlate on the left to an archaeological time scale from late Pleistocene into early Holocene. Don't worry too much about the names. All right. Now, first we need to say how we're going to make these maps. And it's not just raising sea level, but we're using an extensive amount of coring that was core studies that were done by John Anderson's students at Rice over a number of years. And they're shown there in red. There's lots of them in most of the Texas bays and some Louisiana ones. Let's just zero in right now on Galveston Bay, that area in the black there. And let's take a look at a cross section using those cores. There's two cross sections here. The first one goes east to west across the fluvial channel, which is that deep thing in the upper cross section. And in the lower cross section, this is along the axis of the Galveston Bay. And you can see the various cores with dates on them, 7,000, 9,000, whatever. Those are all core dates from the cores. And that allows us to put timelines across the geology so that then we can make a series of maps, which you can see in the upper part of the screen, from about 10, 11,000 years ago to today, showing the development of Galveston Bay. So do the same with the rest of the bays. So off to the left at 2,500, as you can see, that first map, it's just strictly a fluvial channel. And then by, say, in the middle, 8,200, you see in green a bayhead delta starting to fill the thing in, but the bay itself is moving landward. And by the present day, which is off to the right, you can see that the bayhead delta is where the Trinity Delta is today. And you've got an open water bay situation. Okay, one other thing, let's talk about the landscape itself. Present day, this is what the vegetation looks like. And if you're looking at what the indigenous people are doing, it's important to kind of sort through this. The piney woods is basically the same pine forest that extends all the way to Monticello and across the south. The floodplain forest, that's those cut and fill big rivers, are shown in yellow, and they were home of a large floodplain forest, which by now, certainly the Brazos and Colorado River valleys were chopped down by enslaved labor for cotton plantations back in the day and are still cropland. But at the time we're talking about, these were forests. And then finally, everything that's not colored in is open prairie, tall grass prairie, and coastal marshes. Now, we're going to add some archaeological site data using a database that Leland Patterson developed 20, 25 years ago for the Houston Archaeological Society. What we did in this project was to take that data, which had never been located on a map. It was just a flat file of information on arrowheads and stone items and animal refuse that was left behind at these sites. And we updated them for this project. Now there's two colors there. This is what you're seeing is a map of just the late prehistoric and early historic period sites. So that's about 1400 to 400 BP, more or less the last 1,000 years that these Native Americans lived on the coast here. And in red are soil middens. That's just places that basically old trash heaps where the artifacts are mixed in with soil. And then along the coast, you'll notice a whole bunch of blue dots. That's the location of coastal shell middens. So this is where there's a large number of shells of a clam called Rangia cuneata, also some oysters, but mostly Rangia clams. And the reason they form there and form inland is that they like brackish water. They don't like open marine water. They like brackish. So a mix of fresh water and seawater. And that happens at the heads of these bays and in streams coming down the coast. So you see that the Rangia lives up until about 12, 15 miles inland. And that can kind of define a line we call the brackish water limit. So any of the streams coming into the coast would have brackish water and be a good place for these indigenous people to live. Every time they ate a meal, they left a pile of these behind. Yeah, the next thing, so what I can kind of define here is three main places where Indians were living on this coast. One is the coastal zone we just talked about. Second is along the big rivers. And if you notice, the Trinity River is the one in the middle with, let's see if I can point, oh, I can't, not having a good time with that. The Trinity River is the one with all of the, in the center of the map with all the sites. Here they were living on catfish, alligators, turtles, that sort of thing. Very good living, rich coastal resource, also deer, of course, in the adjacent forest. And then finally, there are these hunting zones off to the left. This is in the prairie. And what you're seeing is archaeological sites lining very small creeks. And it's a very important zone. And what was happening is they were running bison into these zones and used them over and over again. This is something noticed by a lot of people in the early exploration days in the Great Basin, and also in Texas. But basically, you could run them in, maybe using fire, maybe not. But if you run them into these incised stream channels, these are small incisions from the same fall in sea level that we talked about, left behind. And in Texas, typically they're 10 to 30 foot drop offs into these forested streams. And by doing that, these people who of course had no horses and no bows and arrows until the very end could get the drop on bison and harvest them. Yeah, so what we see from projectile point data and also from ethnohistoric data is that the Akokisa lived along the coast in historic times and lived off of clams and oysters in the warm months, and fish, of course, and then moved inward in the fall for bison. We were coming down from the northwest, seeking in the winter time, seeking greener grass along the coast. In the Brazos in Colorado River area, they came from their haunts along the coast, and the same thing in the fall. They went up into the prairie to these basically bison traps, and then finally up in the north, the Bidayat, who are also part of the Atakapa tribe, along with the Akokisa, they migrate into the Grimes Prairie from their normal living sites along the Trinity River there. Also, hunters were coming in from the coast. These are the Tonkawa. Let me show you quickly. Let's just blow up this area of the Katy and San Bernard Prairie and take a look at a map. This is just archaeological sites here shown in red. And you can see it's kind of a helter-skelter site, a site map until you put on the drainages. And then if you'll notice, so you've got three large areas of forest: the East Texas pine forest to the north, the Brazos River in the center, and then the Colorado River. And then in between, you have all these small creeks that are forested creeks. And notice how they all open up to the northwest. And it's these creeks that are lined with archaeological sites. The bison were coming from the northwest, from the central Texas plains. And of course, being plains-loving animals, they travel along the prairies. This would be the Katy Prairie and San Bernard Prairie, on their way to the coast in the winter to get that green grass. But to get there, they had to go through basically what looked like a pinball machine. They had to go through all of these, either around or through these forested streams. With a little push from Native Americans, they would be pushed into these sites and then harvested. You can see that these creeks made a whole series of cul-de-sacs that the bison, once forced into those, encouraged into those cul-de-sacs, had no way out other than to hop across the streams, or hop into the streams across those cliffs, to be slowed down and harvested by waiting North American, waiting indigenous Indians. If we take a look at the ages of these sites, you'll see it also in the maps I'm about to show. The colors, it's just a series of rings of the various ages from early Paleo-Indian in red up to late prehistoric in purple. And the remarkable thing about these sites is that over and over again, they came back to the same places, meaning there were good places to trap bison 13,000 years ago and remained that all the way up until the last hunters in historic times. Okay, so let's go through the maps. We'll start here at the last glacial maximum. You've seen this map now before. The lower right just showing you the yellow arrow where sea level is at 125 meters below present. And yeah, the only evidence of Native Americans at this time are at the Gault site out of the area. Nothing was seen so far in our Southeast Texas area. Now I've moved it up to Upper Paleolithic, about 14,500 BP. You can see from the yellow arrow at the lower right, we're at about 100 meters sea level depth. Still no evidence of Native Americans in our area. But then that changes at 12,500. And this is early Paleo-Indian time, or as you can see by those pictures of projectile points, it's Clovis and Folsom time. And these red dots are where we see Clovis and Folsom sites in Southeast Texas. But the thing I want to draw your attention to, shown by that large red arrow, is that the old river canyon is now being drowned. So a long linear bay is starting to form. And there with that light blue turquoise color, I'm just showing you where the Bayhead Delta would be more or less in that area there. So if these Native Americans were going for shellfish at the time, the brackish water zone would have been right about there. So we're starting to form a bay system that's going, as you'll see, is going to move up these rivers. The Katy Prairie and San Bernard Prairie, you can already see that at Clovis and Folsom time, people knew these streams and were starting to utilize them. The other thing to note is that the Colorado and Brazos rivers don't form these bays, and that's because those are much larger rivers that go all the way into the foothills of the Rockies almost, and they're choked with sand and mud debris. So the channels filled immediately with that and never did develop bays. Okay, now we're at a little bit later, 11,500 BP, late Paleo-Indian time. And you'll notice that the bay, as the linear bay has started to move quite a bit further inland as it floods that old river valley. And in light blue there, you'll see I've highlighted two places where you would have found at the time brackish water resources that they could have used. And so we have the beginnings of something that might look like a coastal round where they could live in the coast and then hunt in the prairies in the winter. However, I should have said this from the beginning, we have no archaeological data off in the present day shelf, other than a few places where they've dredged mastodon tusks or whatever out of the coast. There's really not a lot out there. So, but look at the Katy and San Bernard prairies, you see that they're already extensively using these small stream beds for traps. Sea level now, you can see in the lower right where the yellow arrow is, we're at about 43 meters below present day. Now, let's advance to 10,000 years ago. This is late Paleo-Indian time. You can see that the flooded bays have reached in and have now branched. So one of them heading to modern day Galveston Bay, which is at the center right there. And then this will become later Sabine Lake and the Sabine Estuary. This is Calcasieu and then over to Mermentau. So I've drawn again in that turquoise color where the brackish water zones would have been. And as you can see, even though at Galveston Bay, it's kind of coming on shore, that's still underwater of the modern Galveston Bay. So we can't visit those sites. Let's see. Katy Prairie, again, extensive use continued extensive use of there, suggesting that there was a seasonal round from this site where they would have enjoyed brackish water, clams and that sort of thing into the prairies to hunt. If we use the present day as a key to the past. 9,000 years, now you can see that those old river canyons are extensively flooded, and the shelf is rapidly sinking, only a few islands left. You can see that now we've got the beginnings of Galveston Bay. Again, this is all underwater, the present Galveston Bay, as that old canyon system continues to flood. Same canyon system over here, continuing to flood. Again, continued hunting in the Katy and San Bernard prairies. Now it's 5,000. Now look on the bottom and you'll see that we're in the period of the little lower right where the yellow arrow is. We're now really only about 5 or 10 meters below present day. The Galveston Bay now extends, you can see its present day, more or less its present day shape as it continues to flood. And if you notice, let's see if I can do this. Yeah, if you notice around the western side of Galveston Bay, there are 2 dots. Those are the first of, those are the oldest of the coastal shell middens that we see archaeologically. And so what it said is that the brackish water zone, along with the encroaching seawater with rising sea level, has moved onward and moved landward, and we see evidence at those 2 sites in the middle into the middle Archaic, and again continued hunting here. So here we can clearly see that there was most likely a seasonal round like we saw in modern times. And finally, this is the one you've already seen. This is late prehistoric, early historic. So about the last 1,000 years that Native Americans were around this area. And one thing you'll notice here is the number of sites relative to the last period. Let me go see. Well, I can't go back, but anyway, there's been a remarkable increase of, there we go, from the middle and late Archaic sites to the late prehistoric and early historic sites. You can see a large increase in the number of archaeological sites. Why is that? One reason is climate. We have a wetter climate during this period than we had before. Second, probably bow and arrow was introduced. And third, ceramics were introduced to this area. This area was very late getting those technologies for this hunter-gatherer people. All those things were probably the cause of an increase, or at least thought to be the cause of an increase in population at the time. Okay, so in modern times, then we can start to see where the native peoples were living at the time. This is from the ethnologist Swanton in about 1952, showing where the various Native Americans groups were living at the time when Europeans first started coming into the area. In green, you'll notice the Attakapaw tribe, which has a number of bands around Galveston Bay, the Akokisa, further inland, the Bidai along the river, the Trinity River, and then further to the east, the Attakapaw band proper, Calcasieu, Mermentau, Vermilion, each one of those tribes surrounding a separate river system. Down the coast were the Karankawa, and inland the Tonkawa, and up the north the Caddo. Now, it's a strange thing about these tribes, especially the Attakapaw. They're what's known as a linguistic isolate, a language isolate, meaning that they appear to develop completely differently than the rest of the tribes. And you know that because they share very, very few words. If you take the word 3, for example, and you go across Western Europe, you can go from Russia and the Slavic languages to the Celtic languages in Scotland, Ireland, to Latin languages and the Germanic languages on the continent, all those places off a vast area. You know, a word like three is the same word. It's three, tres, dry, toi, tree, all the same words, no matter who's speaking it, saying that they all had a common linguistic root. But if you look at the word for three with these native groups, you'll notice that there's absolutely nothing similar to them. And that holds for a lot of these common words that you would suspect should be similar. And what it's saying is that the Atakapa developed in a very remote way, an isolated way. Karankawa is another one that's thought to be in language isolate. So I think you might be, you kind of wonder why the Akokisa off to the left of Atakapa territory and all the way to the east of Vermilion and Mermentau, they all spoke language, basically the same language with dialects a little bit, even though they're on completely separate river systems. Why didn't they have a larger difference in language? And I think you can kind of get the feeling for why that is. If we follow these brackish water zones through time that I traced on the maps for you as we went through them, you'll see that they kind of trace up the old river valleys and branched off into these various places, showing that culturally, that would have been the same group sometime in Clovis time or thereabouts, early Paleoindian time, and then it later branched into all of these so that the linguistic roots seem to make sense. It also seems to make sense if you look at their creation myths. They have a flood myth, just like most groups in North America, but they also had one that said their origin was that they came out of the sea being cast up in large oyster shells from which the first men grew. That's not a bad creation myth for a group that has been fleeing in front of advancing seawater for 13,000 years. So with that, I'll stop. Thank you very much.